As corporate networks have evolved in recent years, IT departments have had to adapt to security challenges that never existed before. Back in the 1980s, to access data, the terminal on your desk had to be hardwired into the mainframe. The only other way to access secure information was to use a phone modem, and even then you still had to have a username and password, which was centrally controlled. The only problem back then was to ensure that the username and passwords were not compromised. Compare that to today's security challenges created by the new era of digitization. More organizations are accepting the bring your own device or BYOD practice as a normal way of doing business in order to make employees more productive. Internet of Things, or IoT, promises to gather and store huge amounts of data from thousands of endpoints and literally provide real-time analysis. This, coupled with wireless access, virtualization of services, and more organizations moving resources to the cloud, creates a security nightmare. It almost seems impossible to keep track of the infinite number of devices used to connect to the network in order to adequately provide secure access. This is where Cisco Identity Services Engine, or Cisco ISE, provides a centralized network access control and policy enforcement solution. Cisco ISE provides secure network access control for users and devices. It allows visibility into everything that occurs in the network. This includes information on who is connecting, what device is being used, where are they connecting, what time of day, and how they are connecting, such as wired, wireless, or VPN. Cisco ISE supports Cisco TrustSec policy to implement software-defined segmentation of the network in order to help quickly detect and mitigate threats. Cisco ISE also uses the Cisco Platform Exchange Grid, or PX Grid technology, in order to share data with more than 50 integrated technology partner solutions. This way, multiple security products can work together to contain threats quickly and efficiently. The Network Access Device, or NAD, is the point of access where users and devices connect to the network. This can be a wireless connection to an access point, a direct wired connection to a LAN switch, or access through a VPN tunnel via a firewall. This makes the NAD the key policy enforcement point for the Cisco ISE security solution. When using RADIUS for authentication, Cisco ISE acts as the RADIUS server and the NAD is the RADIUS client. The NAD sends the access request from the connecting device to Cisco ISE, which can use a local database for authentication, or a back-end service such as Microsoft Access Directory or LDAP. When the users and devices connect, there are different mechanisms that can be used. Corporate users typically authenticate using the IEEE 802.1x protocol. Guest users may authenticate using the WebAuth mechanism. And network devices such as printers may use MAC Authentication Bypass or MAB to gain access. Regardless of the mechanism used, in addition to Cisco ISE authenticating a request for access, it can also provide access control for the device. This includes mapping traffic to a specific VLAN, using dynamic or named access lists to restrict access, or by deploying a Security Group Access or SGA solution to establish a cloud of trusted network devices. Using Cisco ISE as the network access policy engine simplifies the delivery of consistent and highly secure control across wired, wireless, and VPN connection. Let's take a look at some functions available with Cisco Identity Services Engine, or Cisco ISE. We'll start off by examining the two authentication, authorization, and accounting, or AAA protocols supported. AAA is basically used to authenticate users, authorize what they can do when connected, and keep an accounting of what they're doing. The first AAA protocol is RADIUS, which is a distributed client-server solution designed to block unauthorized access to the network. The RADIUS client process runs on Cisco devices which are designated as network access devices, or NADs. When a user or device attempts to access the network, the NAD challenges the device and sends the authentication request to the RADIUS server running on Cisco ISE, which in turn references an internal or external database. When successfully authenticated, the network access is granted to the client. There are three mechanisms that can be used when clients connect to the network: IEEE 802.1x, MAC Authentication Bypass, or MAB, and Web Authentication, or WebAuth. 802.1x is the strongest method and should be used. However, administrators can configure MAB and WebAuth as fallback mechanisms if the type of client to be connected is unknown. For example, a device can be configured so that if 802.1x authentication times out, MAB can be used to authenticate. If MAB authentication fails, then WebAuth can be used. Let's take a closer look at each mechanism. First, 802.1x is a client-server-based access control and authentication protocol designed to restrict unauthorized clients from connecting to publicly accessible LAN ports. This can be wired, wireless, or a VPN connection. A client or supplicant connects to a NAD, or authenticator, that challenges and forwards the access request to an authentication server, which must validate the client's request before any services are offered to the LAN. Next, MAB is used to authenticate the MAC addresses of endpoints that do not have the ability to perform 802.1x, such as printers. In order to use MAB, a centralized database of MAC addresses for all trusted endpoints in the network must be created and maintained. When an endpoint is connected, the NAD examines a single packet to learn the source MAC address and validate it as a defined trusted device. Once the MAB authentication process has succeeded, the endpoint identity is now known and all of the subsequent traffic from that MAC address is allowed. Lastly, WebAuth is a Layer 3 authentication mechanism that works with any client running a browser. This makes it easier for contractors, vendors, and others with unmanaged devices to gain access to the network without having to install any special software. For example, a guest portal could be configured for people who wish to use the company's network to gain access to the internet or even access certain resources and services provided on the network. Moving on, the second AAA protocol supported by Cisco ISE is TACACS+, which is typically used for device administrators who must access network devices. When connecting to a network device, the administrator can use SSH, Telnet, HTTP, HTTPS, or a direct serial port connection. When a network device is configured for TACACS+, a username and password is requested. The device queries the Cisco ISE server with the credentials provided, which in turn references an internal or external database to authenticate the device administrator. After a successful session has been established, only the authorized commands can be issued, and the activity can be logged by the accounting feature. A quick comparison of the two AAA protocols reveals that RADIUS uses UDP while TACACS+ uses TCP. RADIUS encrypts the password only, and TACACS+ encrypts the entire body of the packet, adding a TACACS+ header. And RADIUS combines authentication with authorization, while TACACS+ follows the AAA architecture by separating all three AAA functions. Let's look at some more Cisco ISE functions. First of all, Cisco ISE provides the ability to implement posture compliance. This means that it is possible to validate and maintain a level of security for any client that attempts to access the network. This is done by employing posture policies to make sure that the connecting client has the security updates or any required applications installed. If a device meets the requirements of the organization, further access can be granted with change of authorization or COA messaging. If devices are non-compliant, they can be forced to remediate the issues before access is granted. Posture compliance can also be integrated with mobile device management or MDM servers to manage mobile devices. When integrated, Cisco ISE can retrieve the policies from the MDM server and then enforce those policies when users register their devices. If the Cisco ISE device policy requires MDM and the mobile device is not compliant, then the user is just redirected to the MDM onboarding portal. Next, the profiling service in Cisco ISE is used to identify devices that connect to the network along with their location. Based on key characteristics, the devices are profiled using endpoint type profiling policies defined in Cisco ISE. Granular permissions can be granted according to the results of this evaluation and determine what a user can do based on the device being used to access the network. Self-service device onboarding makes it easier for an organization supporting BYOD. Employees can manage their own devices according to the business policies defined by the IT administrators. By using a self-registration portal, employees can get their devices onto the network without requiring IT assistance. They also have the ability to blacklist and wipe out lost or stolen devices and then reinstate them if found. Guest management can be controlled using portals as well. For example, a sponsor portal allows sponsors to create temporary accounts for guests, visitors, contractors, or customers to gain HTTP or HTTPS access to the network. It's also possible for guests visiting a company to gain limited access to the network on their own using a guest portal if provided. Finally, the Cisco ISE homepage, also known as the dashboard, is the landing page that provides a centralized interface to perform administration tasks as well as display real-time monitoring and troubleshooting data. The navigation tabs and menus at the top of the window provide point-and-click access to all of the other administration features. This interface is designed to make it easier to access the information needed to make critical decisions in a timely fashion.